Question 17 offers us a factorisation of a quadratic. Now, given this is a non-calculator paper, this should be able to be solved by inspection. As these numbers are all quite close, I'm going to pick 3x and 2x that would produce 6x squared. Now, what would produce 4? Well, it could be 4 and 1. If I put a 4 here and a 1 here, I get potentially 8 and 3. I just happen to be lucky because we can arrange the signs such that that will work. This 8x generated here and this 3x will have to produce a negative answer. So this will have to be negative and this will have to be positive. So that will be the answer to part A. So in part B, we've got to take our results of our factorisation to show when the quadratic is less than 0. We know that because we've got a positive coefficient of the x squared term, our quadratic is a U-shape, and the roots will be found at these 2 points here. Now, to find these two values, we've got to set this quadratic to be equal to 0. Because if this quadratic is equal to 0, our results from part A will be equal to 0. It means that either the first term is 0 or the second term is 0. If the first term is 0, I get x is equal to 4 over 3. And if the second term is 0, x is equal to negative a half. So this point is negative a half, and this point is 4 over 3. Now we've got to bring back this inequality. We want to know when the curve is less than 0, and the curve will be less than 0 between our 2 points. Not equal to our 2 points, but just inside both of them. So how do we express that numerically? Well, x will be in the middle, and this will be 4 over 3, and this will be negative a half. So it will be between the two, and all we've got to do is put two inequality signs in between. We can't use the less than or equal to sign because we're told that the curve must actually be below 0, not equal to 0. So let's remove those again, and that will be the answer.